Okay, so we're given cosine of pi x. We're trying to find the Maclaurin series for cosine of pi x. Why is it called Maclaurin series? Because we're centered it at 0. So this thing up here is the general form of a Taylor series. The difference between Taylor and Maclaurin is Maclaurin, all these a's are 0. I just write them there in every problem, and I would just memorize this or keep it handy for when you take the AP exam. So it's all based on derivatives, right? First derivative, second derivative, the nth derivative. When you have lots of derivatives or a number of derivatives beyond 2, essentially, you just put the number of derivatives you're talking about inside parentheses as a superscript. So I need to find the first derivative of cosine of pi x. So the first derivative is going to be negative the sine of pi x. Now the second derivative is going to be negative pi squared cosine of pi x. My third derivative, which I'm going to be lazy and write it as 3 dashes, but typically I put that in, I typically write it this way, f3 of x. Just wasn't paying attention. Since derivative cosine is negative, this is going to be positive now, so pi cubed sine of pi x, and then so therefore my fourth derivative of x is going to be pi to the fourth cosine of pi x. It asks for a 4th degree Tim McCarthy polynomial. Shout out to Tim. So now I need to plug in 0 because my a value in this one is 0. So f prime of 0, I just plug in 0 here. Well, sine of 0 is going to be 0, so this term is 0. The sine of, so this is going to be, I'll write this as the second derivative of 0 is negative pi squared, the cosine of pi times 0. Pi times 0 is 0, the cosine of 0 is 1, so this is just negative pi squared. The third derivative, which I'll write like this, at 0, well, the sine of 0 is 0, so this term goes away. And the fourth derivative at 0 is going to be pi to the fourth cosine of pi times 0. Pi times 0 is 0, the cosine of 0 is 1. 1 times pi to the fourth is pi to the fourth. I also need to know the function value at 0, so I'll just write this over to the side, f of 0. Plug in 0 to this thing, you just get 1. So our approximation, or our 4th degree approximation of our Taylor polynomial, so the subscript 4 denotes that I'm going to go out to the 4th degree, right? And that's why I have the 4th derivative here. So f of 0 is 1, so that's 1, plus f prime of 0 is 0. So I really don't need to write this term out here, but I just want to make sure we're all on the same page. Whether you know it or not, there's a little factorial, 1 factorial underneath here. X minus 0, again, you don't need to write this term out because it's going to go away. My second derivative is negative pi squared, so this is negative pi squared over 2 factorial, x minus 0 squared. So this 2 and those 2 numbers are always the same. My third derivative is 0, that's the term that's not, it's kind of hidden here. So this is 0 over 3 factorial, x minus 0 cubed. My fourth derivative plus my fourth derivative at 0 divided by 4 factorial, x minus 0 to the fourth. It asked for a 4th degree polynomial because it knew that notice the odd terms all go away. So cosine, when you write out cosine, it's only going to have even powered terms. So my 4th degree Maclaurin, meaning I'm centered it at 0, for cosine of pi x is going to be 1. This term goes away. This is negative pi squared over 2 factorial, x squared, plus this one goes away. This is pi to the fourth over 4 factorial, x to the fourth. So there is my approximation. So notice that this term and this term are always even. So I feel like this is going to be x to the 2n over 2n factorial. And then I'm going to put a little sigma in front of here. And typically for Taylor and Maclaurin problems, oops, sorry, I ran out of room. Notice that this is, that was squared, so I put these are all even, right? 2 and 2, 4 and 4. So that's why I have 2n there. I have -1 to the n and to infinity. Why do I have -1? Well, notice every other term is going to be negative. It's positive, negative, positive. I'm assuming the x to the 6th term would be negative. Notice that I plug in 0. You typically start at 0 when you're talking about Maclaurin or Taylor polynomials. This is the series definition for it. If I plug in 0 here, I get -1 to the 0. I get x to the 0 over 0 factorial, which is 1. So that gives me that term there. I plug in 1, I get -1 to the 1, which gives me negative. Plug in 1 here, I get x squared. I get 2 factorial. That one works. I plug in 2. That's going to be a positive. That's going to be 4. That's going to be 4. So that works.